Alright lads, so just a little bit of revision on the Ellipse question for Junior Cert Tech Graphics. Okay, so these are different principles that you need to know in order to solve the majority of higher level Junior Cert Tech Graphics Ellipse question, which is question 6. And also these little principles will come up in the short questions as well from year to year. Okay, so it's just important to know them. Now, this is just one example here. So I have a line AB, okay, and a point P. So we're told, given the major axis and a point P, find the minor axis and construct the ellipse. Okay, so this is one little problem I just did up myself just to show one of the principles. Okay, so we're given the major axis and we're given a point P. Okay, so forgot to put here, point P is a point on the curve. Okay, so P is a point on the curve. We want to find the minor axis from here and construct the ellipse. Okay. So what do we have here as a start? Okay, so we have the major axis. Okay, we notice the line AB is my major axis. Okay, we have the center of my major axis, which is this point. So if I have my major axis, and have my center point, that means I can draw in my major circle, and that's what it will do. Okay, so I'll get my compass. I'll set it to half the length of the major axis, and I'll swing my circle around. Okay. Now, so that's my major axis and major circle complete. Now, I know my minor axis is going to be somewhere along this line. Okay, so it's going to be in the center point of my major. My minor axis is going to be parallel to my major axis, and it's going to be going through the center point of also my major axis. So what do I have now? So I have a point P. I have a line AB, which is my major axis, and I have a circle. So I need to find the minor axis from here. From point P, we're going to use the concentric circles method, and we're going to reverse it in order to find my major axis. So I know to get, from any point, if I go from my point P, okay, if I bring a line, it's going to be parallel. So this line here is going to be parallel to my major axis, or my minor axis, okay, so because I know my minor axis is going to be this way. I'm going to also bring a line parallel to my major axis from my point P. Okay, so going inwards like this. I'm going to join the point where I intersect the major axis back to the center point. Like this. And now, the distance from the center, which I'm going to call point C, to this point here is going to be the radius of my minor circle. Okay, so just construct it in. So that's going to be the radius of my minor circle. Okay, we see it's fairly small. Okay, and that's that. Now, that construction will work for any point on my for any point on the curve. Okay, so we see the dot line there. I'll just draw this in. I brought up is parallel to my minor axis, and this line here coming from P is parallel to my major axis. Okay, now just to show how that works. Okay, so we see that this is the exact same principle I have drawn here. So take this point here as my point P. I brought a line up parallel to my minor axis. I brought a line across from P parallel to my major axis, and then where that line intersects my major circle, I brought it back to the center point. And we can see that from any point in my curve, so even if I had that same thing over here, it's the exact same principle. Okay, parallel to my minor axis, parallel to my major axis, where it intersects the major circle, back to the center, and that gets me the radius of that. Okay, I'll just bring it down. It doesn't matter whereabouts on my circle we go, or on my ellipse we go, it's the exact same thing. Okay, now so the rest of the question was asking us to construct the ellipse from there. Okay, so once we've that done, we can just construct the ellipse as we usually would. So we're dividing it up using our 30-60 set square. Okay, and missing one. Okay, so here's from here. Now, okay, so I'll divide my circle up into 12 parts, and I'm going to bring lines down. Okay. Okay. Now, so I now have a series of points on my ellipse. Okay. And we see the point P is now on my curve also. So this ellipse is very narrow. And we see that everything I did here, so to get any other points, is the exact same principle. So this here is parallel to my major axis or minor axis. This point here is parallel to my major. Okay, so let's draw that in. Like that. Okay, and that's my ellipse completed, and my point P is on the curve. Okay, so that's if we have a point P and find the minor axis. And it's the same principle if we have the point P and we need to find the major axis. Okay, you're going to bring from your point, you're going to draw a line parallel to both the major axis, line parallel to both the minor axis. Okay, and work it from there. Now the next one we're going to look at is this one here. Okay, now so this time I'm given two focal points and a point on the curve. Find the major and minor axis and construct the ellipse. Okay, so there's a couple of things left in or there's a couple of things to learn in this one. So I have two focal points, F1 and F2. I have point P. Point P is a point on the curve, we're told. Okay, I need to find my major axis and my minor axis this time. Okay, so what do I have? I have a center point. Okay, so I know the distance, half the distance. If I bisect the line joining the two focal points, that's going to get me the center of my ellipse. I know the two focal points lie along the major axis. Okay, so I know that this line here, my major axis lies somewhere along this line, but I'm not sure what the length of that line is. Okay, so what do I have? So I have two focal points and a point on the curve. Well, if you join one focal point to a point on the curve, and this can be for any point on the curve, okay, back to the other focal point, like this. Now, by adding the distance of F1 to P back to F2, so that these two lines added together will give me the length of my major axis. Okay, so the distance from one focal point to a point P back to the other focal point is equal to the major axis. Now, so if I bring F1 around, rotate it around P, so I'm just at rotating this point around to here, that's giving me F1. Okay, so F1, P, F2, and this line here is equal to my major axis. Now, so how do I get that up here? So I know that I have to bisect my major axis. So I'm going to bisect that line. Okay, so that's get me the center point. Now, I know that that distance there is half my major axis. I know this is my center point, so I can bring it up here and I can draw in my major circle. Like that. Okay, this point here, point A, and point B, that's giving me the length of my major axis. Okay, so from here now I have to find the minor axis. Okay, so we can go ahead and we come back and do the same principle as we used in the previous question over here. Or another thing is what we can do is I know my minor axis is somewhere along this line. Okay, so I know my minor axis is somewhere along this line. So I want to find the minor axis. Well, I know that half the length of the major axis swung from the two focal points, okay, where the two of them intersect is going to give me one end of the minor axis. Okay, I'll do the same to the far side. Now, join them 2 points. Okay, so that distance here is equal to my minor axis. Now, just to show that here, okay, so this is my model here, and this principle works for any point on the curve. Okay, so I've said that the distance from one focal point to P back to the other focal point is equal to the major axis. So, on this model here, I have my 2 focal points marked in. Okay, now I'm going to join a line back to point P. Okay, I'll draw it back to here as well. Okay. So we see that the distance from this focal point up to a point in the curve back to the focal point. Now that's equal to the major axis. Okay, so how? We see no matter where I bring that around, okay, it's going to be equal. We see here just when I'm bringing it down, these 2 lines, this line here is going to kind of lap in over itself. Okay, so we see it's coming back around. Okay, so we see, I'll just delete this. Okay, so we see that length, okay, and this length here is equal to the major axis. Okay, bring it back around, and it works the same principle here. So no matter what point on the curve, the distance from the focal point to a point in the curve back to the other focal point is equal to my major axis. Okay. And we said that the distance from a focal point to the top or bottom of the major axis is also equal to half of the major. Okay, so the distance from the focal point to the either top or the bottom of the minor axis is equal to half of the major axis. Okay, and that's something we need. You need to know. You need to know as well. Okay, now so from that there, then once you have that, you can go ahead and construct the ellipse. Now, so the final one I want to look at, so I'll just bring it back to this one here again, and what I'm going to do is I want to construct a tangent to the ellipse at the point P. Okay, so I'm going to take this point, so I'll take a different point, okay, so I'll take this point here, I'll call it point Q. Okay, so on this ellipse, I want to construct a tangent to the ellipse at the point Q. Okay, so first thing I need my 2 focal points. So I know that to get the focal points, I'm going to get half of the major axis, swing it from the top or bottom of the minor axis to where it intersects the major axis, and that's giving me these 2 points here. Okay, so I have F1 and F2. Now, I want to construct a tangent. I know a tangent is a line that touches a curve at one point only, and I want that point to be point Q. So what I'm going to do, I'm going to join the focal point to the point I wanted to touch. Okay, and I'm going to extend it out through, like this. I'm going to do the same from the other focal point, and also extend that out through. Now, so we're going to put these in blue actually, just to show. Okay. Like this. Okay. So now I'm left with a couple, with 4 different angles here. So I'm left with an angle here, say. I'm left with an angle here. Okay. Now, so I need to bisect one of these angles in order to find, and the bisector of that angle is going to give me the tangent. Now, so common sense tells me that tangent has to touch the ellipse at one point. So if I bisect this angle here, and the bisecting line of that is going to run like this. And I know if that's the case, it's going to touch the ellipse at this point and also up here somewhere. So it's going to touch the ellipse at 2 points, so it can't be a tangent. Okay, if I bisect this angle, this is going to be the bisecting line here somewhere. Okay. It's only going to touch the ellipse at 1 point, okay? And this angle here and this angle are both the same. Okay, now so I'm going to go ahead and bisect that angle. So again, put the point. Okay, I'm going to join that bisecting point to point Q. Okay, and now this line here, this red line here, is going to be my tangent line. It touches the ellipse only at the point Q, which I specified, okay, and at one point only. The line that is perpendicular to that tangent, okay, in other words, the line, if I bisected this angle here, is what's known as my normal. Okay, so the normal is at 90 degrees or is perpendicular to my tangent. Okay, and my normal is going will touch the ellipse at probably 2 different points. Okay, so the difference in a tangent and a normal is the tangent only touches the ellipse at 1 point, and the normal is at 90 degrees to the tangent. Again, this principle will work for any point on the curve. Let that point Q be down here or up here. We join the focal point to point Q, okay, join it back to the other focal point, bisect the angle to get the tangent. Now, so just to show it what's happening here. Okay, so I'll just get rid of this here, here, and here. Okay, so same thing I have here. So I'm after joining my focal point. I want to get at this point up here, and I join that back to the other focal point. So I want to get a tangent line to that. Now, so I'm just going to draw in a line here. Okay, I'm going to make that line instruction. Okay, and I want to make that line tangential to the curve. Okay, just to show what's happening. Now, so that tangent line, okay, so a tangent is an infinite length line, okay, and I wanted to touch only at the 1 point. So we see if I zoom in, that line is only touching the ellipse at just that 1 point. Now, no matter where I bring that around, so if I bring that to here, so if I want to find the tangent to the ellipse at this point, it's going to be the same principle. I'm joining from the focal point up to the point I want, back to the other focal point, and if I had extended that line, okay, so I'll just make it sorry now. Why won't it come out for me? Okay, make this line and this line collinear. Okay, there we go. Now I'll do the same here. Okay, so that's the same as what I'm after doing here. Okay, so I got my point. Sorry, now I got my point from my focal point. I extended out through to the point. I extended it through from the other focal point to the point I want. Extended it through, and I bisected that angle there. Okay, so we bisected this angle, and that line that bisects is giving me with tangent. And it doesn't matter where I bring that around, it's going to be the exact same principle. Okay, so I hope this helps.